Hi, this is Tom, and we're going to continue Lesson 12. And in this one, we were talking about order of operations, and another one we need to know is what's called the square and the square root. So let me show you. And we saw this a little bit in the earlier one. The square, let's start with the square, is an exponent of 2. This is an exponent of 2. And now, for example, if I have the number 3 squared, then what I would write is that means 3 times 3. Well, 3 times 3 we know is 9. And that is how you square a number. And we'll try one more. For example, if I have the number 5 squared, what that means is 5 times 5, which gives me 25. Now, let's take a look at the undoing of the square, and that is the square root. So, if I have something like 9, what you have to do is you have to remember that 9 comes from the number of 3 squared. So if I want to find the square root, and we use this symbol here, it's called the radical. Radical. It has nothing to do with political stances or someone that is trying to change the world. It's just called the radical. If I can take the 9, the number inside of the radical, and I can write it as something squared, which we just learned is the same as 3 squared. Then what happens is the radical and the exponent you can think of as canceling each other. And so the answer is 3. So let's try another one. What if I ask you to find the square root of 25? Well, you might say, after a bit of thought, you might recognize that 25 is the same as the number 5 squared. And because you can write 5 squared, then we know that the square root and the square cancel, and we're left with 5. All right, let's try a harder one. Let's try this. Let's try the square root of 484. Now, wow, I'm not even sure if that one exists. Well, sometimes they're not so easy to see. And when that happens, I would encourage you to start trying squaring numbers. For example, let's try 20. If I took 20 and I squared it, well, that would be 400. That's not big enough, so let's check the next one. How about if I took 21 and I squared that? Well, you know what? We've got Good Grapher handy. Let's go check. So if I come over here to Good Grapher and I take 21 and I square it, and notice it's got this button in the bottom left that's squared. That's how you would square it. And go equals 441. Wow. All right. So we're at 441. Well, that's not 484, so let's try again. How about 22 squared? Well, let's go back to Good Grapher and see what happens. So if I go to Good Grapher and I take 22 and I square it, there it is, 484. All right, so let's go back to what we were working on. So 22 squared is 484. In other words, I can actually take the square root of 484 because, and this is critical, because I can write 484 as 22 squared. If this step doesn't exist, then there isn't an answer. And we'll deal with that in a moment. So the square root of 484 is 22. Okay. Now, here's an interesting one. Let's try this. Let's try the square root of the number 2. Well, let's see. Is that a perfect square? Well, if I take 1 and I square that, I get 1. What if I try 2 and I square that? Well, that's That's 2 times 2, but that's 4, so that's far too large. What if I try 1.5? So if I tried 1.5 and I squared it, well, I can actually do that one for you. That works out to be 1.5 times 1.5, but that's 2.25. Interesting. So here's kind of a visual of what happens. This, if I take a number and I square it, it really is what you think of. It's two sides of a square. That's right. So if I have the square root of 2, well, what this comes from is here. If I had a square, or a triangle, the half of a square, and I connected the sides of the square, and this is a simple square with just sides each equal to 1. The distance across that square isn't 1, or across this diagonal here. This is called the diagonal. The diagonal is actually not 1. It is the square root of 2. It's the square root of 2. And the Greeks knew this a couple thousand years ago, and they couldn't deal with it because they thought all numbers could be written as a fraction. Well, here's where the difficulty falls. If I ask you to find the square root of 2, there's two answers that you might write. There's an exact answer, and there's the approximate answer. Okay, let's do both. If I asked you to simplify the square root of 2, the answer is you can't. The simplest way to write the square root of 2 is very simply the square root of 2. Now, here is an interesting twist. Let's find the approximate answer of the square root of 2. And this is what I think most of us tend to default to unknowingly. So I'm going to go back to GoodGrapher. So here we go. Go into GoodGrapher. And I actually have this in this bottom left-hand row. It's hardly, you have to kind of look at the screen. Next to the right of the x squared button, we have part of the radical. That's how I take my square root. So if I want the square root, oh, we could try 484. That's the problem we just did. I need to close my parentheses. If I press equals, there's 22. We could have done it that way, but then I don't think you would have really understood what squaring meant. So let's try 2. So let's find the square root of 2. And notice what happens. Wow! I get this long answer, 1.4142136562. Now here's the interesting part. That number that you're seeing on the screen is not the correct value, because the square root of 2 goes on forever, and the pattern never repeats. So as soon as you stop writing the square root of 2, you've already not quite written the square root of 2. It's kind of a strange idea, but most of us don't like writing so many decimals. How about I round the square root of 2 to the nearest, how about the hundredth? So 1.41. If I look to the right of the 1, I see a 4, so it turn that, all the rest of those become 0. And so what I could do is this. I could say that the approximate answer for the square root of 2, and I use a wiggle sign to mean approximate, is 1.41. And you already saw in the calculator that it could be written with more numbers. And if you look it up, like on the internet, you can find it out to 1,000,000 digits, and they still could keep going. So sometimes the best way to write the number is exactly as you've written it. And there's more of these numbers like the square root of 2 than there are numbers like the square root of 9. But that's something for another day. All right, with that idea, let's try a few more square roots. For example, let's find the square root. Oh, I have an idea. Let's try the square root of a fraction like 9 25ths. There's a couple ways to do this. One is this. You could notice that this is the same as saying the square root of the number 3/5 squared. Well, the square root cancels the square, so that's 3/5. That's one way to go after it. Another way to tackle this is this. If you had the square root of 9/25, you can work the numerator and the denominator on their own. You can think of this as the square root of 9 over the square root of 25, and that's perfectly acceptable. We already said that the square root of 9 is 3, and we also found that the square root of 25, that's 5. So that's how you would work with a fraction. So let's try one more. How about the square root of 1/2? The square root of 1/2. Well, this is kind of interesting. For example, if we break it into two pieces, we have the square root of 1 divided by the square root of 2. Well, the square root of 1, we already said that 1 is the same as 1 squared. And the square root of 2, well, that one can't be changed. So the exact answer would be 1 divided by the square root of 2. This is exact. And the approximate answer well, to find the approximate, we need to go back to Good Grapher and find that decimal. So here we go. Let's go back to Good Grapher. So I'm going to take the square root of 1 divided by 2, and I need to put that in my parentheses. Hit go, and there it is, 0.7071. Let's round to the thousands. So the 707, and then since the number after the 7 is a 1, we'll stop there at 0.707. So let's go back. And the square root of 1/2 is approximately, and I should fix my symbol, is approximately 0.707. We're going to stop there, and in the next video, we're going to one more step for lesson 12, and that is going to be how do we substitute these numbers into a formula. See you next video. Thanks for watching.